A group of 7 companies began the development of USB in 1995: Compaq, DC, IBM, Intel, Microsoft, NEC, and Nortel. The goal was to make it fundamentally easier to connect external devices to PCs by replacing the multitude of connectors at the back of PCs, addressing the usability issues of existing interfaces, and simplifying software configuration of all devices connected to USB, as well as permitting greater data transfer rates for external devices and plug-and-play features. Ajay Bhatt and his team worked on the standard at Intel. The first integrated circuits supporting USB were produced by Intel in 1995. USB 1.X. Released in January 1996, USB 1.0 specified signaling rates of 1.5 megabits per second, low bandwidth or low speed, and 12 megabits per second, full speed. It did not allow for extension cables due to timing and power limitations. Few USB devices made it to the market until USB 1.1 was released in August 1998. USB 1.1 was the earliest revision that was widely adopted and led to what Microsoft designated the legacy-free PC. Neither USB 1.0 nor 1.1 specified a design for any connector smaller than the standard Type A or Type B, though many designs for a miniaturized Type B connector appeared on many peripherals. Conformity to the USB 1.X standard was hampered by treating peripherals that had miniature connectors as though they had a tethered connection, that is, no plug or receptacle at the peripheral end. There was no known miniature Type A connector until USB 2.0 revision 1.01 introduced one. USB 2.0. USB 2.0 was released in April 2000, adding a higher maximum signaling rate of 480 megabits per second. Maximum theoretical data throughput 53 megabytes per second. Named high speed or high bandwidth, in addition to the USB 1.X full speed signaling rate of 12 megabits per second. Maximum theoretical data throughput 1.2 megabytes per second. Modifications to the USB specification have been made via engineering change notices, ECNs. The most important of these ECNs are included into the USB 2.0 specification package available from USB.org, Mini A and Mini B connector, micro USB cables and connectors specification 1.01, Interchip USB supplement, on-the-go supplement 1.3. USB on-the-go makes it possible for 2 USB devices to communicate with each other without requiring a separate USB host. Battery charging specification 1.1. Added support for dedicated chargers, host chargers behavior for devices with dead batteries, battery charging specification 1.2, with increased current of 1.5A on charging ports for unconfigured devices, allowing high-speed communication while having a current up to 1.5A, Link Power Management Addendum ECN, which adds a sleep power state. USB 3X. The USB 3.0 specification was released on November 12, 2008, with its management transferring from USB 3.0 Promoter Group to the USB Implementers Forum, or USB-IF, and announced on November 17, 2008 at the SuperSpeed USB Developers Conference. USB 3.0 adds a new architecture and protocol named SuperSpeed, with associated backward-compatible plugs, receptacles, and cables. SuperSpeed plugs and receptacles are identified with a distinct logo and blue inserts in standard format receptacles. The SuperSpeed architecture provides for an operation mode at a rate of 5 gigabits per second, in addition to the 3 existing operation modes. Its efficiency is dependent on a number of factors, including physical symbol encoding and link level overhead. At a 5 gigabits per second signaling rate with 8B10B encoding, each byte needs 10 bits to transmit, so the raw throughput is 500 megabytes per second. When flow control, packet framing, and protocol overhead are considered, it is realistic for about 2/3 of the raw throughput, or 330 megabytes per second, to transmit to an application. SuperSpeed's architecture is full duplex. All earlier implementations, USB 1.0 to 2.0, are all half duplex, arbitrated by the host. Low power and high power devices remain operational with this standard, but devices implementing SuperSpeed can provide increased current of between 150 milliamps and 900 milliamps by discrete steps of 150 milliamps. USB 3.0 also introduced the USB-attached SCSI protocol, or UASP, which provides generally faster transfer speeds than the BOT, or bulk-only transfer protocol. USB 3.1, released in July 2013, has two variants. The first one preserves USB 3.0, quote, S SuperSpeed architecture and protocol, and its operation mode is newly named USB 3.1 Gen 1. And the second version introduces a distinctively new SuperSpeed Plus architecture and protocol with a second operation mode named as USB 3.1 Gen 2, marketed as SuperSpeed Plus USB. SuperSpeed Plus doubles the maximum signaling rate to 10 gigabits per second, later marketed as SuperSpeed USB 10 GBps by the USB 3.2 specification, while reducing line encoding overhead to just 3% by changing the encoding scheme to 128B 132B. USB 3.2, released in September 2017, preserves existing USB 3.1 SuperSpeed and SuperSpeed Plus architectures and protocols in their respective operation modes, but introduces two additional SuperSpeed Plus operation modes, USB 3.2 Gen 1 by 2 and USB 3.2 Gen 2 by 2, with the new USB-C fabric with signaling rates of 10 and 20 gigabits per second, raw data rates of 12 and 24 megabytes per second. The increase in bandwidth is a result of two-lane operation over existing wires that were originally intended for flip-flop capabilities of the USB-C connector. Naming scheme. Starting with the USB 3.2 specification, USB-IF introduced a new naming scheme. To help companies with the branding of the different operation modes, USB-IF recommended branding the 5, 10, and 20 gigabits per second capabilities as SuperSpeed USB 5 GBPs, SuperSpeed USB 10 GBPs, and SuperSpeed USB 20 GBPs respectively. In 2023, they were replaced again, removing SuperSpeed with USB 5 GBPs, USB 10 GBPs, and USB 20 GBPs with new packaging and port logos. USB 4. The USB 4 specification was released on August 29, 2019 by the USB Implementers Forum. The USB 4 2.0 specification was released on September 1, 2022 by the USB Implementers Forum. USB 4 is based on the Thunderbolt 3 protocol. It supports 40 gigabits per second throughput, is compatible with Thunderbolt 3, and backward compatible with USB 3.2 and USB 2.0. The architecture defines a method to share a single high-speed link with multiple end device types dynamically that best serves the transfer of data by type and application. During CES 2020, USB-IF and Intel stated their intention to allow USB 4 products that support all the optional functionality as Thunderbolt 4 products. USB 4 2.0 with 80 gigabits per second speeds was to be revealed in November 2022. Further technical details were to be released at 2 USB Developer Days scheduled for November 2022.